Okay, so good afternoon, everyone. So welcome to the second week of Flutter Intermediate Training, KodeCamp 4.0. In the last week, we looked into some, data Dart concepts. Talked about generics. We just did a brief intro into OOP and a little other stuff, right? So we're going to go into Flutter from this week, and but I want us to start from should I call it a bottom to top or top to bottom? I don't know which particular statement is going to be pretty much valid, right? But I want to start off from the project structure phase to down to wherever we need to go to, right? So we're going to be talking about, firstly, today, we have two things to talk about today. We're going to be looking at the Flutter project structure, and then we'll get into testing, right? So this is just the first part of it. Okay, so talking about the Flutter project structure, yes. So this is one very, very important, aspect, in your development journey, right? It's not enough to just write codes, right? But you should be able to structure your project such that it is readable, maintainable, right? And, of course, in the long run, something that can scale. And there have been two major ways, to actually structure your project that has been in discussion for a while, which is the feature first approach or the layer first approach, right? So we're going to just look at two of them and then get to know which one actually what works. So let's move to the next slide. So I think, okay, so give me a second. I think I need to reload this slide. Seems that the picture is not rendering. So just give me a second. Reload this. Okay, but basically, so we'll just look at the feature first or layer first. So let's get to know which one is actually. So it's not really like a best practice kind of thing, or this is best. A lot of times it's just dependent on what you're working on, right? How large, what it is you're working on and the scope and everything, right? A lot of it is just dependent on that. So so let's get into that. Okay, think we should be good now. Let's see. Okay. Yeah, okay, so we're good. So let me just quickly share this. Okay. Okay, so confirm you can see my screen. You should be seeing a Flutter project structure. You should be seeing an image. So just confirm that that's what you're seeing. Hello? Can someone confirm that's what you're seeing? Okay, good. So this is the basic Flutter project structure, right? So this is how the feature first looks like, and this is how the layer first actually what looks like. So you can see from the feature first, right? We have this, we have your lib folder, which of course you already know, your SRC, and then we have features. Now, under features, we have feature one. Under feature one, we have presentation, application, and all the stuff. Under feature two, same thing. Now you can see the layer first, right? We have our lib, our SRC. We have the presentation folder that has feature one and feature two. We have the application that has feature one and feature two and all those stuff. So let's just get into that. So first of all, right, it's actually best to consider project structure in relation to your app architecture, right? So for reference, right, we're going to consider this high level architecture, right? We'll consider this high level architecture that is made up of 4 layers, which is the presentation, which is the application, the domain, and the data. So you can see from the presentation layer, right? Basically what you're seeing there is that it has the widgets, you have your states, you have your controllers, right? The application layer has to do with the services, domain layer has to do with your models, and then the data has to do with your repositories, DTOs, and data sources, right? So these are the more like the 4 layers, right? So the thing is, if your application is complex enough, right, you definitely have multiple features. And each feature can be represented by a group of classes that belong to either of these 4 layers, right? So in this context, we have 2 choices, right, with regards to project structure, which is the layers inside features. Remember, these are layers: presentation, application, domain, data. So we can have these layers inside the features, or we have the features inside the layers, right? So let's move. So we have this. I think this image has gone down a bit. My slide is kind of messing up a bit. Let me just solve. Let me bring this up so you can actually see that. Okay, yeah, it went up. Okay. Okay, so I think that should be fine now. Okay. Yeah, okay, I think this is better. So let me share again. Sorry about that. Okay, audience window. Yeah. Okay. So let's take a look at this, right? Let's take a look at this. So remember, like I said, we're going to consider, right, the what's it called? Your project structure in relation to the app architecture. So let's look at this example here. We basically have you have a product authentication cart, right? These are features. There's something I'm going to explain later, Asha, but let's just see these are features, right? Product authentication cards, they're actually features. Now, under the presentation layer for products, you could have your product list screen, which shows a list of products. You could have the product screen, which shows a detail of a particular product. Then you can have, under the application layer, you can have your product search service, right, which could also double as a controller, right? Your data layer, you can have your repository, your product repo, and then, of course, the domain layer, you could have the model, the product class, right? Same thing, authentication, card, and the likes, okay? So now, let's now say, how do we actually structure, in such a scenario, how do we structure, our project, right? So let's look at features inside of layers. So if the features inside of layer approach, which is actually called layer first, it doesn't actually work great for big projects with many features, because for any given feature, files that belong to different layers are far away from each other. And we have to constantly jump, across layers, right? So for every feature, the files that are kind of like, that belong to them, that are kind of related, that belong to those different, they are actually very, very far away. So imagine this. So if we have many features, it becomes hard to find files across layers. So imagine having, let's say, about 20 features here, 20 here, 20 here. So it's going to be a bit, you just have to be jumping up and down, right? And it's going to be difficult to find files. Remember, even inside features, you could have you have other things like your classes or other classes inside that makes up that feature. So it's kind of not really a good approach, right? When you're working with where your project is actually what's big, right? Now, but we have the layers inside feature. Here, each feature gets its own folder, right? Each feature gets its own folder. It's actually called feature first, right? It actually makes things a lot better. So for a given feature, all the files that we need are found inside the same top level folder. And it still gives you a good separation between the layers. So you have a feature 1, which could be the product, and then you have the presentation, you have the application, you have the domain, you have the data, right? Of course, there's still another level of abstraction where you can decide that, okay, fine, you know what, I want to have all domains in one place. You're still using feature first, but you can just take out all domains and keep in just a particular folder. But feature first actually is a good approach, right? Especially when working with large projects, right? So let's take note of that. Okay. Now, So yes, I wanted to say this, right? So understand that features are not screens, okay? Features are not screens. Features are basically functional requirements that help the user to complete a task. That's what features are. So now in practice, actually, these things are not, they kind of sound very easy, right? Because at the beginning of a project, you may not have a good understanding of the domain model. And it's actually very important to consider the project structure from the domain model, right? But at the beginning, you may not have a good understanding of it, and that actually makes it a bit difficult to identify the various features and structure of the project accordingly. Now, of course, at that you'll be tempted to create one folder for each screen of your application, but don't do that. That's actually a mistake because features are not screens. Very important, okay? So features are just functional requirements that helps the user to complete a certain task. That is why we have the cart is a feature. Authentication is a feature. Okay, and what's the function of the authentication? To help the user to be able to authenticate his or herself, sign up, sign in, log out, reset password, and all those stuff. That's a feature, functional requirements. So everything in there helps the user to accomplish a certain task, which has to do with what? Authentication. Cart is a feature, right? Everything that is needed, it could be to add to cart. Product is a feature. You could see a list of products, you could edit a product, you could add a product, you could delete a product. Those are functional requirements that are needed for completing, the whole process of creating a product. Because when it comes to, for example, creating a product, it doesn't just stop at you filling form and clicking on submit. I need to be able to see what I have created. I need to be able to edit what I have created. I need to be able to delete what I have created, right? So take note, features are not screens. Very, very important statement. Features are not screens. So following the feature first approach, you better actually structure your project, right? So, and one of the things that it helps you to do is, especially when you consider getting the structure from your domain level, for example, a product, you get to know every what's it called? Every requirement needed for the product feature, right? So understanding this feature first approach will help you figure out which widget, which controller, which services, which repositories belong, especially when understand the domain. So getting to know which approach to use, it starts from your domain, layer, right? So for a product, what does it take to create a product? Right? What are the parameters? What are all these things, right? So it will help you to know the widgets, the controllers you need to make available, the services, the repositories, and all of that. And of course, that will help you to better organize your projects as a result of that. So that's basically that. It's not rocket science. It's not rocket science. So that's basically that. So let's talk about testing, right? Okay, let's talk about testing. I know some of us have been running away from this for a while. I think somebody even said it in the last class, right? But you're here, so sorry about that. You'll face it. Now, so let's talk about testing. So it's just straightforward, right? Testing actually just ensures that your application works correctly. Okay, it ensures your application works correctly, and it also helps you to catch bugs early in the development process. Another thing it also helps you to do is it helps you it ensures that new changes to your code does not break an existing functionality. Okay, it really helps, and of course that makes maintaining your code very, very easy. So testing cannot be overemphasized. It cannot, right? But of course, there are two types right? Not in Flutter, I'm just going to be a bit more generic. There are two types of testing, right? The first one is the manual testing, and that's what a lot of us just do, right? So in this case, you just write your code, you develop your app or your software, then you test the feature and try to find bugs or defects in the application. Maybe you give it a few persons, get some manual there, some testers, or people should test this feature. Can you sign up? Yes, I can sign up. Can you sign up with Google? Yes, I can sign up. Can you log in? Can you log out? Can you reset your password and all those stuff, right? That's fine. So that's manual testing. But we have automated testing, right? And automated testing is actually just a way to prevent the software from expected bugs, not just any bugs, expected bugs. Now, that doesn't mean that your software does not have any bugs, right? One thing you should understand is that bugs are not just only when you see red lines on your code. Okay, don't worry, we'll see these things. Not just red lines that are bugs. Okay, so automated testing helps you to prevent software from expected bugs, but that doesn't mean that your software doesn't have bugs. It just means that the software does not have any expected bugs. Expected bugs is something that, of course, this is definitely going to be the result based on this input. So if you give me this kind of input, of course I am expecting a bug because you're giving me the wrong kind of input, right? So automated test is better, it's generally preferred to manual testing, right? Let me give you this example. Assuming you're building, okay, let's say an e-commerce application, right? Let's say you're building an e-commerce application, a big one. Now, with manual testing, okay, let me even just pick one. Let's say Amazon, right? Imagine you want to do manual testing on Amazon currently. There are a lot of things to be done on Amazon, right? So you have to rely on a team of testers to check each feature, to check components of your application, to ensure that it actually meets, required specifications, right? So this is a very time-consuming, resource-consuming process. And actually, it is even error-prone and subject to human bias. Let me explain. For example, if you build an app now, to be honest with you, a developer like you, well, maybe let me not really say, someone who is a bit tech savvy, maybe the person is not a coder, is one of the worst persons to actually test your application. Why? Because they don't really look for bugs. For example, if you build an authentication app, this is an example I want to give to you. Let's say you have implemented authentication in your app, right? And you want to test it. You give it to somebody who doesn't understand how to break your code, right? What will the person do? Of course, you tell the person, try to log in. What will the person do? The person will sign up. The person will now in signing up, how many persons do you know? If you're on a scale of, 1 to 10, right? Around your maybe coders who understand how to break code, how many of them do you know would, instead of putting in a password with, what's it called? Certain rules, like putting a character, a symbol, and a number. How many of them do you know will probably do that? Some of them will follow the actual process. Okay, signing up, put first name. Okay, they'll put their first name. They'll put their email. How many of them will probably just, in the place of email, how many of them will just put A or type and forget to put @ Now, the question is how many of you as coders will remember to always check and validate your form, right? How many of you will always do that? Okay. How many of you will always try to make sure that before submitting, it makes sure that, okay, look, an input field that is meant to receive number should only receive number, shouldn't receive letter, right? An input field that's to receive a mail, I should validate that input field, look, if whatever the user types does not match this expression for an email, then it should throw an error. So the question is this: you may have written the code, right? The question is, what if in the process of trying to update something breaks, right? How many users will actually, people will consciously want to just write their email very well. It's just a few persons that will make that mistake. So human test, as good as it is, it's not the best, right? It's not the best. So automated tests right? It's very, very, in fact, it's preferable because you use automated tests to check each feature and the components, and you ensure that it functions as expected before it even goes out. You don't even need somebody to click on this, call this function, right, and expect it, and it should work. No, you have already written a test that makes sure that the function actually works. And this method is faster, it is more reliable, it is more efficient than manual testing, right? And of course, you can test a large number of scenarios in a short amount of time. So imagine how many scenarios you would want to test, right? From a manual perspective, or in authentication, there could be like 10 scenarios to check in authentication. So now, let's say the first part is sign up with email, right? And let's say you test that process of sign up with email without clicking remember me. You want to test it again with remember me. You can't use that email again. You have to create another email, right? And all those stuff. So, but with automated tests, you can have a large number of scenarios. And once you just click run in a short amount of time, it can detect even the smallest of what errors or defects or whatever, right? So automated test is not something to run away from. It's something to run to, especially in the world we are going to now, of course, this whole tech thing. So let's run this quickly, right? The testing in Flutter, right? There are basically three. We have unit tests. Now, these tests, they verify the behavior of individual functions or classes, right? And it's actually fast, and it focuses on testing just a single piece of code, right? We have the widget tests, right? Widget test verifies the behavior of individual widgets. Of course, you understand what a widget is, right? So it basically ensures that widgets are rendered correctly, and the user can interact with it, or it can interact with other widgets, right? And then, of course, the last one is the integration test or integrated test, right? Basically, it's just to verify the behavior of the entire application. You can actually simulate real user interactions and ensure the whole application works as expected. You can use a physical device, or you use you can use your emulator. So quickly, why unit testing? Why? There are many reasons, right? But first of all, unit test helps you to identify bugs at an early stage, right? And that will basically just save you a lot of time and a lot of money. A lot of time and a lot of money, right? The second reason is when you want to actually do a refactoring. So after your code might, after you've written your code, of course, you may get a bit worried, because the truth is, if you've introduced something new, it can break certain features in your application. But when you have unit tests and then you decide to probably refactor, right? Don't worry, there's that confidence that if something goes wrong, your unit test will tell you about it. It will tell you about it, to tell you what exactly just went wrong right now, right? And a third reason is just that it makes debugging very simple. Actually, that's just it. Because when you start unit testing on your project, it makes debugging easy, because now you can know what cases are failing, what test cases are failing, and because of that, that will help you get to know exactly where your bugs actually would lie, right? So that's just more like a brief introduction to testing, right? So we're going to do it now. We're going to do a practical session right now. If it's something you want to join me, well, that's fine. You can just create an empty Flutter project right now, and then we'll just kickstart that. So yeah. Okay, so let's get our hands and see my VS Code. Hello, can I be heard?
Yes,
Okay.
yes, I can hear you.
Okay, good. Okay, so like I said, if you want to join me, right, just you should just have this set up. So when you create your Flutter app, of course, this is like the default stuff that comes, which of course when you run it, it's just your counter application. I'm not going to run it or anything, right? But it's the same code. The only thing I removed were just the comments that it comes with, right? Those are the only things I actually just took out, but it is still it's still the same thing that So we basically have the counter application. And basically what it does is that it has this increment button that when you click on it, the state changes, right? Okay. And then you see 1, you see 2, and you see 3, right? So, but the thing is this, right? That's actually what we want to test. Okay, we want to be sure that, okay, fine, these numbers are actually showing, it's actually incrementing and all those stuff. But we can't actually test this. Now, one thing you need to ask yourself is when you want to actually test is this code testable? Right? The very important question. Now, this code actually, the way it is, it's not testable. And this is why. The reason is because we have this application logic, which, we have this increment counter function. Here we are setting the state and increasing the counter variable, right? So everything is just mixed together. The UI and the logic is all in this same file. So one thing you want to do when you want to test is to abstract things, right? Separate logic from what UI, okay? So that's what we're going to do. So I'm going to separate this logic, this whole logic we have here. I'm going to move it to a new UI. So let me create a file here. I'm going to create a file. I'll call it counter. Let's say counter.dart. Yeah, so yeah, counter.dart. Now, so let's create a class called counter. Sorry, yeah. Now, what I want to do, I'm going to create a counter variable. Of course, I want to believe when you create a variable with this underscore, it means it's private, right? So I'm going to create the one that can be accessible. So I'm going to say in get count, and then this. So this is basic stuff, right? This is basic stuff. So this our getter will just give us the value from when we're calling it from an external, class. Then I'm going to now have a function called what increment what counter. So basically, I'm just going to, I'm basically just going to take this guy out, right? That's basically what I'm going to do. I'm actually going to just take it out because we don't need it here, right? We want to separate the logic from the word UI. We want to separate the logic from the word UI. So let's just do this first. Increment counter. Okay, so what should be contained in our increment counter now, right? Basically, what we want to do is to increase. We just want to increase the counter variable, right? So all I'm just going to say is counter plus plus. Sorry. Yeah, so that's basically what we want to do. So I want to increase this variable. That's all. So when I call this counter variable will be increased, and then it will be stored here, and then I can get it in my main class. So what I'll just do is this in my main class, right? I'm going to create an instance of this here. Let me say final counter post counter. right? So they'll need to import it, right? Good. So with this now, of course, I'm not going to do this again. I'm now just going to say counter, which is the object dot what increment counter, right? And that would actually just call the increment counter for it to what be increased, right? So we don't need this here, right? So that's how we're able to separate the UI from the logic, okay? Which is very important. That is what makes it testable. That's what makes it testable. So here, this will just be counter dot count, right? So yeah. Okay, so we are done. Now we want to test. So whenever you want to test, right, you need to, of course, you go to your test folder. There's a test folder here. Now, okay, I think I deleted it. Of course, by default, you see widget.test, but we don't need that. Now, we need to create a test file where we're going to run our test. Now, one way you could do it is to just go to file, new file, and then just type counter test or whatever. But one thing you need to know is that when you're testing classes, it's always good to, your test file should also carry the name of that, the file you want to test, right? It should also carry the name, right? So what we're going to do, I'll just right click on this counter and then you can see go to test. So when I click on it, you see this pop up here. So would you like to create a test file at test counter.this? I'll just say yes. So you can see it just helps me to create, the test. Now, before then, one thing to also note quickly, of course, I had to set this up due to time so I don't have to start waiting for network, is that you should have your test dependency in your dev dependencies. Why? Because this is just for you. You're not going to start running tests in your live project, right? In production site. So just put this in your dev dependency. This is actually the current, as at this moment, this is actually the current version, right? So 1.24.9, right? So just put this and then we are good to go. Okay, sorry, I think my screen share stopped. Sorry. Okay, sorry, let me share my screen again. My display was disconnected. Okay, so quickly, okay. Okay, yeah, so we're going to use this test folder. So this is where we're going to write our tests, okay? This is where we're going to write our test. So make sure you add this dependency. So let's go to our test folder. Now, this is for widget testing. We don't want to do any widget testing for now. Today we'll just look into unit testing, right? That's what we're going to focus on. Now, when it comes to testing now, right, the unit testing, what do? We need to, of course, there's a convention, right? The first thing you need to ask yourself is, what scenario, what is your test case? Okay, what is your test case? Which is a very, so we need to, that's something to figure out. Once you decide your test case, then you now test for that particular case, right? You now test for that particular case. So let's unit test our counter class. Okay, so I'm going to say test. So I'll call the what test this thing. And then this is what it says. You have to give a description, right? And we have to pass in a function, right? We have to give a description and then pass in a function. So the description is basically what you want to test for, right? It's basically what you want to test for. So in this our case, right? Let me just add, okay, we already have this. Okay, so let's just test, let's test this increment what counter. So for a description, your description can be whatever, right? You can say that check that this is where English language comes in. Let's see, which grammar will I use? So let's say check that the value of count is 0, right? So what do we want to do? Remember, in our counter class here, we first of all set the counter to be 0. That's the very first thing. So when you even run the application, you should see 0 first. That's the first thing. So we want to actually check to be sure that 0 is what initialized. And of course, that's what it should be because that's the default value. But let's just test it, right? So check that the value is what? 0. So, and then I'm just going to take this out and then we'll pass in, what we want to test. So we want to actually test that. So what we're going to do is I'm going to create an instance of the counter class. I'm going to just mock it. Right? So I'm going to create an instance and then I'm going to say, fine, let me get the count. Yeah. So okay, so, and then we close this out. So what have I done here? I've done two things. The first thing is arrange. Now, the first thing you need to do is to what? Arrange, which is what we have just done, which is what? Creating the necessary things that is needed, right, to run the what? Test, right? The next thing after that is what? The act. Okay, which is what we are doing. So now we have gotten the things where we're now taking an action. Okay, we are now checking. This is where we're actually what? Checking, right? That's the, so we want to now confirm what count is. And of course, when you run it the first time, we want to be sure that we are getting what? A 0, right? We want to be sure that we're getting a 0. Now, after the act, we now have the assert, right? So this is where you do your check. I want to check that the value is actually what? 0. So to do that, Flutter has this expect that helps us. So here, what you basically just do, you pass in the actual value, right? And the actual value is this value that we just got from here. And then the matcher is what are you matching it to? Okay, that is the expected what value. Okay, so I'll say 0. So what this means is that I am expecting my value here to be what? 0. That's what this means. Okay, so we arrange, we take an action, and then we assert. Okay, so let's run this and then let's see if our test will pass or fail. Okay, so let's see. The thing I clicked on, yeah, so let's run that. Let's hope it's not taking much time. So let's check. So test this, yeah. So we can see, check that the value is what? 0. So that actually, the test actually passed. You can see this arrow here, right? We ran it twice actually. So you can see this here, the test passed. Let me switch So we have this icon here, testing. So you can see this here. So our test has actually passed. If assuming I expect 1, now is it possible to expect 1? Of course, you can expect anything. But if I run this test, it will fail because it is not, you're expecting 1, but the value is 0, because once you create an instance of this, the initial value of count, right, is 0. But here you're saying that you are expecting 1, and you can see that here that we have this error. So test failed for this test case to check that the value of count is 0. It expected 1, right? That's what it expected, but the actual value is 0. It expected 1, which was the one that we put here, right? Here, but the actual value was 0. Okay, so that's basically just that's basically what unit testing is about, right? So let's take it back to how it was before. Let's run the test again to expect 0. I think my laptop is doing too much, so it's pretty much a bit slow. Okay, so yeah, so that's that, right? So let's see what else we can test for. Let's see what else we can test for. Now, let's now check that it actually increments, right? Let's check that it actually increments. So when you press the button, right, when you click on the button, you're basically calling the function increment counter, assuming this was on your app. Now you click on it, and what happens? You should go from 0 to 1, right? When you click on it again, it should go from 1 to 2. When it goes just like that, to keep on going, right? So let's test that. Let's run another test. So I'm going to say test. So what's the description? So I'll just say check that count is incremented, right? Yeah, I could just put that. Check that count is implemented. I think that's fine. So description sometimes it should actually be clear. But let's say check that count is incremented. Let me just be a bit more distant and say and value of count is 1. So let's first thing first is to arrange, right? I'm running through the process again. So arrange, let's set up everything that we need, right? Now I'm going to call this, I don't have any counter class created here. Remember, of course, this is more like a scope thing. So just because we created this here doesn't mean we can call it in this for tests or that test file. So for adding, I want to take an action, and the action I want to take is to call the increment function. Okay, so I'm just going to say counter dot increment counter, right? Now, after doing it, of course, I need to now get the value. So I'll just say, which is counter dot count, counter dot count, and then the last thing assert. So I'm going to say expect. Sorry. So what am I expecting? I'm expecting that my the value rather, should be 1. So after we increment. Okay. So I'm going to run this and then let's see. Let's see. Let's see. Okay, so I think it's still running. So yeah, so you can see the check that the count is incremented. So you see the test passed, right? Our test has actually passed. So that means we are getting a headway. So Another thing we can do is another thing in testing is you can group tests, right? You can actually group tests. So more like instead of having to write them, especially if they are, related or they are with respect to one class. For example, we are testing the counter class now. You understand? We're testing the counter class. And all these things we are testing is still with respect to the counter class. Okay. So how can we do that? Right? Let's see how we can actually do that. It's actually very simple. All you just do is I'm just going to come here and then say group. So with group, we'll now give a description. So I could just say counter class. Now I'm going to add a hyphen here and I'll show you why. I won't want to run when we are running the code actually. So then inside, I'll just take all these and then I'll put them in here. Okay, so I don't need to click on this run to run these individual tests, right? I don't need to. All I'll just click on, I'll run the group, right? I'll run the group. That's just what I now need to do. I'll run the group. And then when I run the group, it will run every test that is in that group. Or I can actually just run the main function also. So let me run the entire function and then let's see what we have here. Let's pay attention to this place. So just a second. Okay, yeah. So we see it actually runs the two of them, right? So you can see, let me close this out, right? So we have the test slash the counter test file, right? And then we have this counter class, okay? And inside you can see the two tests that is what inside, and they all what pass, right? So everything passes. The group itself, the test in the group passes. The individual tests also what pass, right? Of course, it's possible for a test in a group to actually fail, right? It's also very, very possible. So that's actually that for tests. Now, we can also do some other things, right? Let's assume we have I could create a decrement counter. Let's assume I want to decrement. Right? This is basically to decrement, right? So of course, what we are doing is what we want to do is to send more like do a bring it down, right? That's basically what we want to do. So let's write a test for that one, right? Let's write a test for that one. I'm just going to, so let's just do it one by one. So test, let me just take this, right? So I want to check the count is decremented and the value of count is -1. So of course, we're going to do this. We're going to create an instance. And of course, when you create an instance, right, the initial value is 0. Okay, so calling the decrement function means you're saying 0 minus 1. And of course, that's -1, right? So let's test that. So let me just get this actually. So yep. So this will be the decrement counter. So let's do something, and then here we're expecting a -1, right? So I want to, let me hide this. Okay, so let's run this guy. So let's run all of them. Let's run all of them and see if all the tests will pass. So you can see all tests passed, right? So 3 out of, you can see here, 3 out of 3 actually what passes, right? 3 out of 3 passes. And then we'll open that, you can see that. So there's something we can do here, right? There's something we can do here. Now, if you notice, since this is a group, having this, you notice we are just repeating, we are just creating an instance for every test, right? We are creating an instance for every test. Now, since this is a group, having to create this for this group doesn't actually make any sense, right? It actually doesn't make any, it doesn't make any sense. It defeats, in fact, it defeats the process, the need for a group, because you should be able to, you know, kind of have a particular variable or instance that is common to all of them. So I'm just going to take this out, right? Take this out. Take this out. And then I'm now going to declare it in the group just before the first test. So this now becomes a global object, global instance that every of the tests can what leverage what from. But let's see something. So let's run this. Let's run this. And yeah. So good. Now notice something, that we now have one test that is failing, right? We have one test that is failing. Can anybody tell me why? Can anybody tell me why why one of these tests is failing? Anybody? 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 Yeah, David, go ahead. David, your hand is raised. Go ahead. Hello? David, are you there? Okay. Anybody else? I think David is not.
I can't actually see what the code is. The stuff is blocking the screen. This I don't know what this is. Can you hear me?
What is blocking the screen?
This
The error.
Yes, exactly. This thing is blocking. I can't see the code behind.
Okay. Can you see it now?
Yes. Okay. The last test failed, right?
Yes. So can you tell us why the last test failed?
I think it's because, you used a kind of a counter object you use the same counter object for the test one and test two. And in the test one, you incremented it, making it one. And in the test two, you decremented it, making it zero. So zero is not equal to -1.
Okay, so Collins, is he right? Hello, Collins, are you there? You're unmuted. You want to say something?
Okay, I'm Collins, I'm the one talking. I said the reason it failed is because
I thought this was David who was speaking.
Okay, no. It's me,
Go ahead.
Collins.
Okay.
I said the reason the last test failed was because previously you are using a counter object for each of the tests, but now you shared one counter object for all the tests.
Yeah.
And in the first test, you incremented it. Sorry, in the first test, check it for 0, which passed. In the second test, you incremented it, which made it 1. And in the last test, that's the third test, you decremented it, which put it back to 0. And 0 is not equal to -1, which was the expect condition.
Yeah.
So I think that's what that feels.
What do you think the solution would now be? Assuming I want to make sure that this test passes, what do I have to now do?
Is either you change the expect, the matcher parameter of the last expect to 0, or you add the reset function to the counter such that after each test you reset it.
Well, we don't have a reset, do we? We don't have a reset now. So, well, I get your point. That's if we don't buffer, of course, there's nothing in our code that resets our counter. You understand? So,
Yeah,
which that would work if we had something that resets it after every what's it called? But of course, if we
modification.
after every test that has been run, we reset. That means we're setting the instance back to 0. You understand?
Yes.
And that would actually now make this work. Or we could just, take back, make sure that all of them have their own instance. You understand? So
Yeah.
if I give all of them back their instances under the arrange, right? For example, this one, right? If I run this, right? So I'm
Yeah.
creating an instance here, right? So this
Yeah.
should actually now pass because at the point of testing this, I'm creating an instance. And in creating this instance, it means that our counter variable is now actually 0. So you can
Yeah.
see that it passes. Okay, good one. You're following. So any questions before I go forward? Any question before I go forward? Okay, Collins, go ahead.
Okay. My question is, how do you test asynchronous functions? Like, I would like to see an example if there's any.
We'll get there now, young man. In fact, you will
Okay.
get there, not even me, because it will be part of the thing we need to do. But they are not, it's not really, see, testing is now looking at the concept. It's very important to understand the concept. You arrange what you need
Yeah.
to arrange, right?
Mm.
You make the necessary actions, you put whatever you're expecting. For example, whether it's asynchronous, it's not asynchronous, right? For example, if it's a future, you're
Mm.
expecting something, right? So
Mm.
it's for you to be able to, okay, we'll do an example actually, right? I'm not in this class, but I think in the next one, we'll do an actual
Yeah.
example where we'll work with we'll just mock a kind of back end, not really back end, API call, right? And we'll get
Okay.
to actually test models, right? What if for example, I have a list of users somewhere and I'm fetching
Yeah.
those users? How can I test that whole process? You understand? Without actually having to open the app and then run it and all those stuff like that. How can I actually do all those things? Right? We'll do it. Don't worry, it's part of it's part of the plan. Okay, that's why we're here. But
Okay.
of course, one of the things you guys need to understand is that part of being in the intermediate level means that I should be able to introduce a concept to you,
Mm.
and you can take that concept and run with it. You
Yeah.
understand? It's for beginners that I have to now start breaking down, and like the class I had earlier, you have to break down and break down and break down, right? Even after that, yeah, but not for you guys. You guys is once I introduce a concept to you, right? You should
Yeah.
be able to pick it up and fly with it. Of course, you have challenges there and all the stuff. That's where I now come in. Okay, okay, I was trying to do this. This was the issue, and then we come together, we break our head. There's one of the thing I want all of you to understand is, see, there is nobody in tech that knows it all, right? Nobody in tech
Yeah.
knows it all. The best of developers that even still check ChatGPT. The best of them, they check Stack Overflow. You understand?
Yeah.
Why?
Yes.
Because
Yes.
nobody's a monopoly of knowledge. And that's one thing. I don't even pride myself as someone that's why I am open to, oh, okay, you're having this issue. Oh, yeah, let's join the call. What do you think? What do because do you know that for some of you, do you know how you understand this thing? Probably try
Mm.
to teach somebody, right? One of the things you'll
Yeah.
find out is that you see errors this person will have that you've never seen in your life. Why? You did not take the same approach the person took when you were learning. You understand?
Yes. Yeah.
In my little time of teaching, there are several errors when I started actually doing training physically. There are errors that people bring to me, and I'm like, I had to go back home and really, really go and sit on it. Not because I am not smart, not because I'm not their trainer or I don't have experience, but I have not come across it before. In fact, I think one of them, when I was teaching Android, I asked the guy, sorry, what did you do? What, how,
How did you arrive at this?
how did you get to this place? And you see it, stuff. If you check or if you go online, you check GitHub, there are certain this thing you do, you see errors people drop, and they'll now show you the process. They'll say, okay, this is how to replicate that problem. Why? Because they have not seen it before. Like, how did you get there? Why? The person probably took a route that you probably would not have taken in your learning process. Or the person went to go and try it and now we got stuck. And then they'll now come and meet you. So that's one thing I've learned over time. So that's just on a lighter note. So yes, we will test all those stuff. We'll run testing. We're going to build stuff. And one thing I want you guys to know is for every project we work on, especially when if you're to get to the final stage where we'll now work on a live project, we are going to follow best practice. We'll follow the process. We will first of all write tests before we even start doing any major thing. We will write tests first. That test that some of you are running away from, you will first of all write it before you even start doing any major coding or all those stuff. You will write tests first. You write it. We'll set up. One of the things we'll do, I think we'll do that on Thursday also. We'll set up tests for GitHub Actions. I think I mentioned that, right? So you guys should go to your set up your Git and everything. We'll do the whole. I'll show you guys how to do the whole YAML file and all those stuff, such that when you push your code, right, in case you forget something, right, we'll just do a simple linting test, just linting. It will check, and your test because of that linting test, your code will fail, and because it will fail, you're not able to actually merge that code. You can't merge it until you fix that issue. That's part of what. So that's the beauty of automated testing, right? So we'll get there, right? But what I'm basically doing is introducing you to stuff that you will fly with. Now, let me introduce us to something else. Now, one of the things in testing you need to try to understand is we need to try to avoid a situation whereby a particular test depends on another, depends on something else, right? We need to try to avoid it like we just saw now. Because we had this counter, everything is hinged on this guy, but the third guy was failing because of this one. So you get to stages where, certain instances, certain objects, certain requirements may actually be detrimental to your testing, right? So we need to be able to abstract things. Now, in Flutter, we have 4 methods that actually that we can use, right? We have setup. Now, setup, this registers a function to be run before your tests. So the setup function is going to be called before each test is actually run. So before any test is run, whatever thing you put in your setup function is going to be run first. And it is actually the body, it may be asynchronous, but if it's so, it will return a feature if you're doing asynchronous, right? So, but if this is called within a test group, it applies only to the tests in that group. So, but of course, I'm calling this outside of this test group. So we have setup, right? We also have set up all, right? We also have set up all. So we think, no, I think it should be, yeah. Okay, so we have set up all. We have tear down, right? That should be camel case. Yes, tear down, and then we have tear down all. So set up all, this one registers a function that will be run once before all the tests. So the setup actually is run before each test, okay? So we have this first test, whatever function we put there will run first, and then it will call this setup, it will run again, call the next test, it will run again, call the next test. But setup all will run once, and it will run once before all the tests, right? We have tear down. Tear down registers a function to be run after a test. So after each test is run, tear down is called. Whatever is in tear down is called. After each test, tear down. After each test, tear down. But for tear down all is afterwards, this registers a function to be run once after all the tests. So after all tests has been run, right, then the tear down all actually what comes into play. Okay, it now comes into play. So these four functions are actually important, right? So they are just various stages in your testing, testing journey. Let me call it testing journey, right? So we can call it, there's one thing, you can actually just say that your setup is actually a I could say call this more like a pre-test, right? Because it's done before, and then tear down is what post-test, because it is after, right? It's after. So that's just something to note. So the question is, how do we actually now make use of it, right? How do we make use of it? So let's see. Let's just play around a bit, right? So basically, one of the things we want to set up, of course, before we do anything is this guy. So let's say I take out this, right? And let's just watch something. Watch what will happen. So if I put this here, so this is a problem, right? Because in the setup, I want to just initialize, the counter class, the counter object. I want to just get an instance so that before any test is run, it actually kind of creates that instance for me, right? But now you can see that it can't even access that variable because, of course, it is a local variable as far as it's concerned. This is a local variable because it's in this scope. So what we can do, I'll just create a late variable. I'll just say counter, and then I will now initialize it in the setup, right? So that being said, let me now take this out. Okay, so what happens here? Remember what we said. So the setup registers a function to be run before test. So before each test. So what happens is this. This is called the first test is run. This is called the next test is run. This is called the other test is run. So let's run this. I'm going to run this from here. Okay, so wait for it to run its course and give us a result in the debug console. So let's see if our test if it passes. So our test passes, right? So you can see before, when we actually created that instance here, right, what happened? It was not, this third one was not passing, right? But now we are creating, based on the fact that we're using the setup function, we are now creating a new instance. We are creating a new instance before we run each one. Assuming I put this in setup all, right? Assuming I put this in setup all. So what does setup all do? Setup all actually, it's actually what registers this function once before all the tests. So this should give us it should fail, right? Because since it just gives us one instance, right? At this point, it should be 1, right? So we shouldn't expect, yeah, so it fails, right? It fails. So that's the thing. So we have a test that this test fails. The decrement actually fails. So that's the difference between the setup and setup all. So of course, what function you put there depends on whatever it is you're testing, right? It depends on whatever it is you are testing for. So that was just a demonstration, right? That was just a demonstration. So let's run this and get back our tests that passes, right? Okay, so that's actually that. Yeah, so our test is actually what passing. So that's actually like the concept of unit what testing. Okay, that's basically the concept of unit testing. So is there any question? Any question? So, okay, so let me do what was it called? This person talked about. So let's assume I want to have a reset function, right? So basically the reset is just to set counter back to 0. Yeah, so just to reset that. So let's go to our tests. Just permits me to duplicate this. So check that count is reset and value of count is 0. So all I have to just do here, I don't need to, I don't need to do any arrange again. All I just need to use is the counter variable dot reset, right? I hope yeah. So now the question is, what am I going to expect? Okay, what are we going to expect? So all I'm going to just say is I'm going to expect that the counter dot count is what 0, because that's what we want to check. That's what we're expecting when we want to reset, right? When we want to reset, we expect that the count variable is 0. So that's basically what we're doing here. So so let's run this and let's be sure. Let's be sure that our test actually passes. Okay, so we can see our test is actually good. Everything is working, right? So you can see that everything is working. All our tests are passing, right? So yeah, that's more like an introduction to testing, right? That's an introduction to testing and to unit testing. Okay, so that's basically what we're going to be covering, right? That's on Thursday. So on Thursday, we're going to go in depth into unit testing, and we're going to be testing. We'll do some actual modeling stuff, right? Yeah, we'll do some actual modeling stuff, but this is where we're going to round it up for today. So, are there any questions before we move?
Okay, sorry, I have a question.
Yes, go ahead.
So in every application that we're making, you see like it's like compulsory for us to test everything, like the unit testing, integration testing, and other.
Okay, so it's not a must. For me, I would say unit testing is a must. Of course, you can't even run from integration testing. Integration testing is basically what you do, when you run your what's it called? When you run it on your emulator, all the stuff to check full functionality, right? So of course you do integration testing. I think the one that people don't always do is in widget testing, right? But it's also important, and we'll touch it, right? We're going to also touch on widget testing, where there are certain things you should test for, right? You can test that a button was actually clicked. We can test that. Okay, typical example is, let's say you fetch a list of products, right? You can test that on clicking on a particular product, it takes you to the details of that product. You can actually run a test on that. Okay, that would what prevents, from a, so if you're able to catch that error, and if you're able to make that test pass, it means that no matter what, if the user actually clicks it, it must always go to the next screen, right? So I think a typical example was, I think it was last week, someone was running a project, right? So he I think it was on React. So he did a navigation stuff, and then he came to meet me and was like, that this one, he clicked on this one, but this one is not working. You understand? He was clicking on a particular button, but it was not responding, right? And that actually brought my mind to testing, right? So if he had written a test for that button, for that, okay, fine. In a navigation bar, why not write a test for that? Then write a test that makes sure that every item on that navigation bar, that once you click on it, it takes you to the particular page that it should. You understand? So yes, we will, right? I wouldn't use the word compulsory. That there may be companies that are not too big on unit testing, right? There may be, but standard, when it comes to talk about standard, which is one of the things we're trying to do in KodeCamp, not just to teach you stuff, but to teach you industry standard and what some top level people look out for, then please do not run away from testing, right? It's not easy, but trust me, it is worth it, and it makes you stand out. Makes you stand out. Okay, Adebowale, go ahead.
Okay, sorry, I had some audio issue the other time. Okay, so my question this time around is that I know that if you notice on your left-hand side of your screen, you could see each of them and attached to it some seconds.
Yes.
Like, yeah, is this test also monitoring the number of seconds it took your code to pass, or it's
Yes.
just the number of minutes it took this test itself to go through?
So it's the amount of time it took your test to actually pass.
Okay, not
And
actually the number of minutes it took for performance in terms of when it was called in wherever it is called from.
So it's not really from a calling perspective. So think of it from a performance perspective.
Okay.
Right? Let me give you an instance. You do know that when you create maybe I'll find a time and then we'll talk about yeah, of course, it's actually part of what we will talk about: memory optimization, performance, and everything, especially with respect to UI. We'll talk about widget trees and everything. But for example, in algorithm, there's what we call time complexity. How long it takes your code to execute. It's part of performance, right? And of course, there are a lot of factors to this, right? There are a lot of factors to this. For example, it could even be your RAM. That's one, right? Your RAM, like currently my laptop is full. A lot of things are running that I cannot stop it, right? Because once I'm done, I have to switch to this and everything. So of course there is that part for impact. There's also the part of how you actually write your code. Let me give you an example. How long, okay, you guys, so let me ask you, assuming we had a function, let's say we wanted to write a function that it considers between if and switch in Dart. So we have, let's say, 4 cases. You know, now with if statements, you may now have something like if A, for example, do this, else if B, do this. We could have a lot of this. Let's say we have like 4 bits, for example, right? So we have the whole of this code. Now, you know, switch in Dart is actually used for more specific, let's say switch letter, just assuming, right? And then in switch, you now have you have what we call case. So case, let's say A, if it is that, you probably, let's say, return something. right? Return, depends on whatever it is you want to return. Yes, just depends, of course, if that is a Boolean that you're returning. And then, so this is a more specific purpose. Now, think about the time it will take your code to make this decision, right? So it has to check this line of this thing. After that, it goes in here, it runs this, it goes in here, it runs this, it goes in here, it runs this. Now, one of the things you should ask yourself, if I'm using a switch and an if else, which one, based on the number of instructions and executions, which one do you think will run faster or will finish faster? So that's also another thing to consider. How you write your code also can determine if your code is going to run faster or slower. How you structure your code, right? Your approach to, the steps to achieve. A typical example is this, right? This is just an example. Cooking of noodles, right? Of course, that's actually a program. It's a set of instructions to prepare noodles, right? Now, there are people who would probably, let's say, want to go. There are persons who will take a different approach. Two persons cannot use the same approach, for example, right, and achieve and end at the same time, because there are other factors, right? There are other factors that comes into play, right? But there are approaches. Somebody might decide to boil water first. After boiling the water, the person might decide to now put the noodles and hold on till it's a bit soft before the person now puts the seasoning. And somebody else might just put cold water, put the noodles, put the ingredients, put it in this thing, close it. Now, in the end, are they making noodles? Yes. The processes, are they the same? No. But who will finish fast? Which one will actually which one will be ready on time? So we'll get to talk about performance, right? It's part of what I have a line for you guys, okay? So we'll get to talk about performance. But yes, this actually just gives you an idea of how long it took your test to run. And that goes as far as saying that it goes as far as questioning the structure of your code, the amount of the steps it takes to actually run a particular function. So here, for example, this test, we have to first of all get called the decrement counter, which the decrement counter already in itself has to do what? First of all, do this. After doing this, it has to return it to this. All those things are time. So you can see that this first one, check that the value is 0, actually took 55 milliseconds, right? The second one that checks for the value of 1 took a lower time, because this very first time, of course, this was the very, very first, this way you're running that instance, okay? So for it to actually, even when we clicked run, remember we clicked run on the main thing, so it had to do this setup. So before this guy could be tested, this setup had to actually be done, right? But you can see after that, the next text, which is decrement, right? Decrement actually took 10 milliseconds, right? Almost the same time. Now reset now took 11 milliseconds. Okay, so you had to go in, reset, and do the whole thing and everything. So that took 11 distance. So that's just the thing about testing. It's very important. Time is very, very important. And you know this when you guys, if you start taking some, if you're someone who does algorithm, or you want to start, you will know the importance of time, the time complexity when writing your code. So yeah, you guys have a lot to improve on, a lot to learn, right? I'm not really here to teach you like a beginner and start drawing screens and show you how to put edit button, flex button. No. That's not what I'm here for. I'm here for a more advanced stuff, more than what you have already done, but things that will actually challenge you to start doing things better. That's basically what I'm here to do. So it's not to probably hold your hand and, okay, for someone, if you're always expecting that maybe we'll come and we'll build one Flutter application and all those stuff. No. We may build one Flutter application now, but that may not even help you. There are a lot of tutorials that builds application, but that means you're just following. How many? After that, if somebody gives you a project that is outside that thing you built, can you actually start it? So I want us to understand concepts, right? Dive deep, know how things work, right? For example, let me ask a question as I round up. What's the difference between flex and expanded? Can any of you quickly tell me? Anybody? Yes, Collins.
Yeah, I think expanded, what it does is when you place a child widget inside it, it takes up the whole space available to the expanded widget. But then flex is you can set flex to take up a fraction of the space available to the flex widget. The child is gonna take up a fraction if you want it to. Understand? But like expanded is not configurable, it takes up the whole space of the expanded.
Yeah. So a typical thing I'm going to now do in this class is not really just come and start using expanded. One of my job is to now tell you, okay, these are the situations where you need to use expanded. These are the situations where you do not need to use expanded. And the question is, how many of us know when and when not to use a particular widget? You understand? And you need to understand that, look, you will not know, there are some widgets you may never use in your life. You may just not use it, right? There are widgets I have used, you will not use. There are widgets that you have used that probably have not used also, right? All is with respect to what you are actually building, okay? So it's a journey, right? This whole thing is a journey. There's no destination yet, right? We are still taking the journey because Google will keep on adding stuff, improving, and we'll have to be learning those new things, making sure we are up to terms to apply those knowledge. So I think that's basically that for today, right? So tomorrow is going to, Thursday. Yes, Thursday is going to be much more hands-on, right? Yeah, we'll now look at we'll still look at unit testing, but we'll now look at a different scenario where you have to, okay, fine, I'm actually fetching an API, right? I'm calling an API, or I'm getting something from, getting something online. How do I actually test? That's one. Secondly is, what exactly am I testing for? Okay, so that will be done in our next class. Okay, so in the absence of no question, thank you very much. And I hope you guys have done your time. Only 2 persons have actually sent theirs to me, right? Only 2 persons have sent in theirs. So I want to expect that.
Hello. I'm sorry, please. I did not actually get the DM where you expect us to send our link to actually.
Discord.
I didn't get that. In Discord.
Discord, yes.
Is there a direct message?
In Discord, not Discord. Are you not on Discord?
Yeah, I'm on Discord. I mean, is there a way to do direct message on Discord? Anyway, okay, I'll just see how to go about that.
Of course not. Yes. Just
Okay.
when you see check my
Messages.
once you click on my username, right? You see a box under
Okay.
input field, yes, for you to start a direct conversation.
Okay.
Yeah.
Okay, I'll do that. I'll do that.
Okay. Okay, so guys, thank you very much. Let's have a wonderful week ahead.